All right, so in this video, we're going to introduce some new problems, of course, but also these involve u-sub. So they're the most basic that we have, so that's the one we're going to start with. The main idea is this radical is going to be giving us an issue when we do our integral. So our goal is to deal with that problem in different ways. So the first thing we have to do for our little formula is to find f prime of x. So that just means take our derivative. So this would be 6 times 3/2 x to the 1/2. So that's 9 x to the 1/2. The 2 and the 6 reduced to a 3 times 3 is 9. Next step is to square it. So we're going to do y prime squared, which means we take our 9 and x to the 1/2 and square it. That would give us 81, and then the square and the half cancel, giving us x. Now we add 1 to it, so 1 plus y prime squared would be 1 plus 81x. And then we end up by just throwing a radical around it. So instead of rewriting it again, we'll do this. So now we have found out what our square root of 1 plus f prime of x squared is. It's 1 plus 81x. Now we can do our integral from 0 to 1. And with u substitution, we always pick whatever's on the inside. So 1 plus 81x. So du would be 81 dx. And so dx is equal to 1 over 81 du. And then we plug it in. So I'm going to put the 1 over 81 outside. We've got to change those numbers from 0 to 1. But this is now square root of u du. So we've done our substitution. 1 over 81 du. The 1 plus 81x is u. Perfect. Now, if x is equal to 0, that means our u would be 1 plus 81 times 0, which is 1. So we're going from 1. And if x is 1, then our u would be 1 plus 81 times 1, which is 82. So at this point, we now have our integral all set up here too. And what we're going to do is use our calculator to verify what this is, get the exact value, and then plug it in the calculator to verify it's correct as well. So if we take out our calculator, let's do a math 9 with that. And we plug it in. So 0 to 1. Second, square root 1 plus 81x. Come on. Dx. Verify everything's correct. We look good. All right. So 6.103 is what we should be getting. So this is equal to 6.103. But again, this is an approximate. It's not the exact answer. It's rounded off. So let's go back. And this is now a u to the 1/2. So we add a 1. So that's u to the 3/2. That's a 2/3. 1 over 81, 82, and 1. So we get 2 over 243, u to the 3/2, 82, and 1. So that's 2 over 243, 82. I think it's the 1. I keep putting 82, 1 there. So 82, the 3/2, minus 2 over 243, and that's just 1. Put 3/2 for the heck of it. All right. So that means over here, this would be 1.5. This is 1.5, which means you get to take 1 out, and there's a radical left. So this is 2 over 243 times 82, square root of 82, minus, and then 2 over 243. So 164 over 243, square root of 82, minus 2 over 243. And yeah, we could keep simplifying, factor out something if we want, but we just want to check to make sure that it's 6.103. And so let's zoom out a bit to get room for the calculator. Bring the calculator up. And there it is. So 164 over 243, blah, 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 blah. You get 6.10. So it's exactly the same. A little bit off here for the round off here on that thing. But there you go. Exact value, approximate. So this is u sub right here. And again, I'm picking problems that are a little bit more work heavy, so that you have every single little trick there is. I'm not going to pick the simple problems for these videos. So let's do one more. All right, same thing again. So we're going to take the derivative. So that's 2x with a negative. And then we're going to square it. So that's 4x squared. And then we're going to take and add 1 to it and put a square root around it. So that would be 1 plus y prime squared. So 1 plus 4x squared, square root, square root. Okay, so we go integral from 0 to 2, square root 1 plus 4x squared dx. And so you can see we're going to be using a trig substitution. So here we want to make our, oops, not u, in this case this is an x substitution. 4x squared equal to tangent squared theta so that we can convert it to a secant. So that means we're going to be using 2x equals tangent theta because we don't want to use the square version. So 2 dx equals secant squared theta d theta. Now we plug it all in. So I'm going to leave off the 0 and 2 and plug them in at the end. So square root 1 plus tangent squared theta. And then we end up with divided by 2. So we have a nice clean dx, so a half secant squared theta d theta. And again, this is just secant theta here because it's a square root of secant squared. So that's just going to become secant cubed. So 1/2 secant cubed theta d theta theta d theta. And we've already done secant theta d theta, so let's go back and look at our previous notes from 7.2. So the integral of secant cubed d theta is 1/2 secant tan, and then 1/2 natural log secant plus tan. So secant tan ln secant plus tan. So 1/2 secant theta tangent theta plus 1/2 ln secant theta plus tangent theta. And then we need to bring in our 1/2. All right, now we also have to convert these back because remember this is 0 to 2 is for x, not for theta. So we come back up here to tangent and put it in green. And our tangent theta is equal to 2x. So that one's nice and quick. We can already plug that in. So that would be 2x, and that would be 2x. And I'm going to convert it to 1/4 now. So all we need now is the secant. This is 1/4 now, ln. And then we just need the secant as well. All right, so if we make our little triangle here, just like before, theta, and this is tangent, so tangent would be 2x over 1. And then so this one went up here, our hypotenuse would be a squared plus b squared with a square root around it. So square root of 4x squared plus 1. That looks good. All right. Secant theta is the reciprocal of cosine, so that would be hypotenuse over adjacent, because cosine is adjacent over hypotenuse. So square root of 4x squared plus 1. All right, so now we can plug that one in. Square root of 4x squared plus 1, square root of 4x squared plus 1. Now we can tack on our 2 points, 2 and 0. Plug them in, we'll find out where theirs. The nice thing is you just relax. We already know from this simple work. See, this stuff is not that complicated here. This is where the complication comes in. So once you get this, you're going to get this. This you can plug in the calculator and get an approximate value, and you'll be able to then just match it to this one. And if they match, you know you're right. All right, so we have 1/4. Oops. It's on blue. Come on. There we go. Blue again. 1/4. Square root of 4, and I'm just going to put in 4 because it's squared, plus 1. 2 times 2 plus 1/4 ln, and again 4 times 4 plus 1 plus 2 times 4. Okay, that's our first one. And then minus the next one would be 0. So 1/4 square root. And then 4 times 0 is going to be 0 plus 1. So that's just square root of 1. And then 2 times 0. Well, that's gone, right? So we can get rid of that because we have a 0. Next one. Plus 1/4 ln square root. And we already know we're between 0 and 1, so we really don't need the absolute values anymore because we're going from 0 to 2. We don't need the absolute values here. But we're going to leave it anyways because I already drew it. And that again is 1 plus 0 All right, so that is 1. So that's the square root of 1 plus 0 is 1. Natural log of 1 is also 0. So all you have to do is worry about the top one. All right, so we have 1/4 times 4. That cancels. So really we just have square root of 17 plus 1/4 ln of the square root of 17 plus 8. I don't like how that's written. I want to put the 8 first. So I'm going to do 2 times 4 first, which is 8, plus the square root of 17. And again, that's 100% positive. So there we go. Now we'll plug this in our calculator with this. So if this one matches this one, we know we're right. And we're not. So let's go back and look. I've plugged in 2. No, I plugged in 4 because I knew the answer was 4. So there's my simple error right there. So this should have been a 2 that's plugged in. Like that. Making this a 4, not an 8. Now let's go back and check it. And there we are. So simple errors you can catch with your calculator. So always make sure you're plugging in your integral to verify that your exact answer is exactly the same as your approximate. And so now I can put a box around it. Everything is good. So these are your U substitutions. In this case, X substitution. It really just means your substitutions. You're going to go back and use trig substitutions, basic U substitution. So when you see that situation, use this. When you see that situation, use this. In the next video, we're going to do squares. So we're going to be taking and making perfect squares out of these.